My name is Slava, and I work for Dutch Royal Academy of Arts and Sciences. And you see a weird suit. I'm Ukrainian, so no complaints about me from the Oval Office. And I'm going to bring data. So you just saw this beautiful talk from Barn Pons about theoretical foundations. And in my presentation, you will get a lot of references to the data that we have. You will have also tools that you can use. And you will get some insight information what we actually do with feral landscape. Okay, so a bit about my organization. So I work also for DANS, which is institute inside of Dutch Royal Academy, and we are basically integrating any kind of data sets from different communities. We are trying also to publish them, to make them fair, and also to ingest everything in knowledge graph. So we are basically trying to force all this collaboration and support scientific research from different fields. So one of the central components that we have is called Dataverse. And originally this platform was developed by Harvard University. And we're a really active contributor, and basically a lot of people coming to us from different communities. They're asking to develop some functionality. We're basically collecting all requirements, we're producing something, some prototypes, and after we're discussing with Harvard how to integrate this in a master branch and to make it available for all people. So this is kind of open source and open collaboration that really helps the world to innovate. And for example, functionality that supports knowledge graphs and semantic web, it's actually my work and my team that we contributed and Harvard adopted, and now it's available for all people from around the world, and this is where basically all these knowledge graphs and innovation really speeding up. And you see, now we're discussing also how to build linked open data and how to use knowledge graphs for life sciences and for biotechnologies. And that really helps if you're working with other partners on this. So Dataverse, and this example of Harvard Dataverse, it has really nice features like export. So there is a button that you can download any dataset in different formats. For example, there is dataset export, which is JSON, and there is JSON-LD, and you can download Croissant, which is what we hope will be AI-ready standard. So basically, the idea that you can connect this export directly to AI, trained model, based on data, and after you can ask questions. I will show you in follow-up slides. Important links. So Harvard Dataverse has about 200,000 datasets. However, in Netherlands, we also have about the same amount. So we are really successful in building Dutch data landscape, and we're also consulting a lot of people from other countries. And for example, French data landscape at the moment looks like Dutch data landscape because we contributed to its development. So in a way, we are building kind of common data space for the whole Europe, and I think this is really important for further development and collaboration. So all these links will be on slides, and you just try that. You will find a lot of amazing data sets, I'm pretty sure. And I just mentioned French and Dutch, but we have 120-something data sets in different countries. So there is a spreadsheet where you can basically find all these dataverses, and you can connect to any of them, and you can get data, and you can query, and you can get all this stuff basically in your knowledge graph, and you can do something with it. So this is important, and it's about 750,000 data sets, which is quite impressive also. And all of this stuff is fair, so it has persistent identifiers. It has also linkages to control vocabularies, and this is really high quality stuff, that best you can get at the moment. We also started to build our own semantic search in Netherlands because a lot of people come to us and they don't have any platform to deposit data. So they're asking us basically to ingest their data sets, their metadata coming from different places, even from FTP servers, and basically publish inside of Dataverse and make it available for other users. So in a way, we're also like trying to make the whole data landscape fair, even bringing our own platforms, and you see it's called Odyssey Portal. So it's a way also how you can aggregate information in a way you are building the same as Google, but only for data landscape. And the point is, it's also multilingual. So we're collecting metadata, let's say, in Dutch, and we're using artificial intelligence also to do translations. So we're able to translate keywords and metadata descriptions, titles to other language. And people can also find Dutch datasets described completely in Dutch with just querying in English or in German and any other languages. So this is also good for like international collaboration, because a lot of people interested obviously in the use of data instead of like producing new data sets. So query and search Dataverse is extremely easy, and Dataverse has really nice documentation. And if you follow this link, or you can just Google for it, you'll find there are a lot of pages describing how you can get something from Dataverse in different ways. And this is like search API, where you can just get some query, you can query it, and there is also JSON LD. So basically all information coming out of Dataverse is already suitable for any kind of AI applications, and you can combine different data sets and you can use it straight away. And this is how it looks like. Also, you can, if you're interested, there is also a web interface, so you can do it. You can do search by hands. Just select some DOIs. We're producing DOIs, sometimes handles, which is persistent identifier. Put with all these DOIs in the system. After connect cursor or something which you are using, and you'll get all data sets directly from network, from data network. Very convenient and very efficient process. You can also combine thousands of them in one process, and yeah, have fun to build something interesting. So if you are really interested to know how to connect Jupyter Notebook, we also had workshop, and there's a link to materials, and you can just clone this GitHub repository and run Jupyter Notebook and try all things, even in local setup, because you can install Dataverse locally on your computer. Now, we're coming to the knowledge graph topic. So knowledge graph is something relatively new for Dataverse, and that's something we started to push from the Netherlands at Harvard, and a lot of countries also joining forces. Already mentioned France. And basically what we do, we are also building a triple store with all datasets coming from Dataverse. And we have also an endpoint where you can query Croissant metadata. I will explain what Croissant means in further slides. And we also have graph visualization, where you can actually visually explore the whole graph. And at the moment, this graph, it's quite big already. It's about 50 million triples. And you can query in milliseconds, because it's also powered by Q-level triple store. And if you don't know what is Q-level, you should really Google for it, because it's really promising, and Wikidata is considering now to switch to Q-level to run own SPARQL operations on it. So just open these links and explore. I don't have time right now. And this is, if someone knows SPARQL, this is excellent feature that you can basically run search across all available dataverses, and you can find information, you can integrate metadata, and you can really do a lot with artificial intelligence, understanding ontologies and control vocabularies coming from this. And if you don't know SPARQL, I assume a lot of people just think that this is something complicated. So it's, knowledge graph concept is something also new. There is another way, basically, to use the same functionality by using traditional search engine. So in Dataverse, we're using Solr. And this is how, basically, any question could be converted to Solr query. And this Solr query you can send back to Dataverse. So in a way, you're bypassing this SPARQL stuff, and you are using traditional conversion to query hundreds of dataverses in parallel, getting back results, integrating those results with AI, and again, so you're fine, you get a lot of data which is useful, and it's in JSON LD, so machine does understand what it's about, and it's high quality stuff. And again, so Dataverse Search API is here. Take a look. Now I'm coming to actually AI stuff. So retrieval augmented generation is getting big, And obviously, we have two different stories here. And what we do with Dataverse, we're building graph. And this is metadata layer in our understanding. So whatever you will be depositing in Dataverse will be converted into a set of triples, like Baran just mentioned. And it will be available in export, and it will be also consumed by AI. So AI will understand what it's about by just using those kind of relationships. From other side, we have a vector. And vector space is quite complicated. Nobody understands what vector means. However, there are also some tools that help you to take projection and basically understand what kind of clusters you have and to get any kind of meaningful information out of this. So our vision is distributed, and basically what we're building is distributed AI, where we have LM interface between human AI, and it's kind of works as reasoning engine. So it's querying metadata in the knowledge graph, getting back results, and trying to do interpretation. So we started implementation on the level of interoperability, and basically Google came with this idea to use Croissant. So this is new standard called Croissant for machine learning. And first, it was implemented at Kaggle, and after Hugging Face, and there is OpenAI is considering, and Dataverse has now implementation, which we basically contributed recently. So we are moving from centralized response, where everything is published on one platform, in one place. So we want to make it distributed. So we don't care, actually, on which platform data is published. Could be Dataverse, could be Hugging Face, could be something else, DSpace. It's not important anymore. As soon as we can get data back in a standard that machine doesn't understand, and we can use it as a kind of language between machines. And in a way, also, this Croissant ML can be considered as a kind of new replacement for schema.org for the future. If you're interested, just take a look on this spec. I'm also one of co-authors, and as I also mentioned, we have integration with Kaggle, there is OpenML, Hugging Face, so all of that is supporting Croissant. And this is excellent because now you can combine something available from Dataverse, 750,000 data sets, with something published by companies, and all this stuff is already available on Hugging Face. Just combine it, find variables, interesting variables, and do something useful, okay? So why Croissant is getting big? We also working on the integration of known machine learning frameworks, basically, of course, coming from big tech companies like Google and Meta. So we have extensions for TensorFlow, PyTorch, and Keras, and all these famous frameworks. And the idea here is simple. So as soon as you have some data set available as Croissant, you can point it to machine learning framework. And you can also find thousands of those data sets, right? And the point is, it will check license, and if there's open license, so it can be basically using this information. So it will go further. It will find all variables available in semantic web way, also with triples. It will recognize them. And now you can basically train your own custom model based on thousands of data sets. You can pick up different variables, combine, train, and now you will get a completely new model, which will be answering your specific question. For example, what will happen to Germany if GDP per capita will be like that, and inflation will be like that? So these kind of questions. Yeah? So this is very useful, and this is where we are going. Now we started also to work on semantic Croissant, which will be also enriched with integration with external control vocabularies like Wikidata and BioPortal, OntoPortal, these kind of platforms. And machines will understand even better what we have in our data networks. So this is how it looks like in Dataverse. If you open any data set, for example, from Harvard or from Odyssey portal, you will have this nice button, Croissant Export. So you can export with JSON-LD, put it in a Jupyter notebook or in any kind of framework you're using, and just build some application directly. And you can also, it has distribution layers, so you can also download files which are interesting for you. And this file will get description, what kind of variables it has, So it's already suitable for the future. We are producing AI-ready data. And for some Dataverses, because of course this functionality is new, and we've got Croissant extension available only starting from version 6.2. And I think about 50% of our Dataverse is still running this old version. So we developed a Python application. It's basically a part of now of PyDataverse. And you can use it in Jupyter Notebook style just to connect to some Dataverse, dataset published in Dataverse. It just doesn't have even functionality to produce Croissant. And it will do it for you, and it will bring you all necessary information to the system, to AI. Yeah, and we're also using semantic mappings, and this is how it's being produced. So why I'm showing this slide? Because in the future, I started to believe that AI can also do automatic enrichment of any data set based on information coming into data network. So you can run something like reinforcement learning, and you can improve metadata quality on every step. As more data will be linked, you can run and repeat process again and again, and it will get more relationships, which could be also exposed to AI. And basically, this is kind of the process that improves metadata automatically. Also with human in the loop, because people creating those links, they are putting links to external keywords coming from controller captures described by human. And you can use also this information to show AI in the prompt what this variable means. So this is very useful. Of course, as I already mentioned, human in the loop is really important because AI doesn't understand without human the meaning. So you have to also think about processes, about tools, how to improve what AI is producing. And we're also using a very nice framework called Dakana. There are a lot of them, but Dakana is from Japan. And we deployed it as a service, and it's very easy to get Dakana running from Docker Compose, and you can use it as a kind of the man in the middle, where you can also double-check, correct some data, and feed it inside of AI, retrain model, and after next time you will get better quality. Another tool, and this is very useful, extremely useful. So I was talking about graphs. And now it's vector space, which God knows what it does. Nobody knows. And even now, there is no clear explanation what LM actually is doing. But you can take projections. So this tool is called Latent Scope. It's a fantastic tool. So, I mean, I've seen a lot of tools, but this is the best tool that can give you impression what you have inside of your model. So you can take projection on any kind of variables, and it will produce nice visualization with clusters and this kind of information. Another important component, I'm pretty sure that people will start to use that as well during Hackathon. So it's called Quadrant, and Quadrant is actually a company from Berlin. And now Quadrant is getting big because it's a vector store. As soon as you're training something, you're producing new vectors, you have to store it somewhere, and also to have possibility to query it. So I really advise you take a look. For large-scale datasets, it's must-have because they also have GPU support. So it's extremely fast. And there is another vector store, of course, very popular, called ChromaDB. And if you have like small datasets, use ChromaDB. And if you have large-scale datasets, you need Quadrant or something compatible. So we're coming to the point where we have two different stories which are contradicting. And I was thinking about this for quite some time, and I came basically to this conception of Mr. Jekyll and Mr. Hyde. So someone who is different at night. So, and this is it has very simple explanation. So in graph, we are basically dealing with dynamic structure. So information could be added, could be edited, and it will change. And as soon as you have model, and especially all these big models, large language models, it will take probably hundreds of millions to train them. It will take, I don't know, half of a year. And as soon as it's trained, you can only fine-tune but not delete information. So it's static, and somehow you should combine both. So what is happening now, because it's quite difficult to deal with large language models, this agentic architecture is basically getting close to graph to query graph to get some information and also use large language models to do processing. That also means that in the future, you don't need actually to ingest information and data inside of large language model. You can also query graph as soon as it will be like high quality and you can get meaningful information. And you can use really small models, let's say 1 billion or 4 billion parameters, and this is what I'm using also. Basically to do basic processing, to understand language, and also to be able to integrate and produce some meaningful results for you. Now, what we will do if we have just free strings. So usually in metadata descriptions of datasets, published on Hugging Face and sometimes in Dataverse and other platforms, you just have a string, and without context, you don't know what that means. So in this example, and that's something we are working on right now, it's a knowledge graph and LLM integrator that can actually predict to which concept from any ontology this could be linked. And the idea here to replace free string with some identifier from ontology, and basically it's also compression in a way. Because as soon as you will get this connection to ontology, you can also get also multilingual translations of that thing and use it also in the prompt. So if someone is asking a question in German or in I don't know, Italian or Chinese, it will recognize also. So large language model will understand the context properly and will give you right results, right? So in this specific example, I'm using Hotel California to query the song. So it's basically, it does querying of Wikidata with SPARQL, getting candidates, and after it's taken similarity between all candidates and selecting a song describing Son of Eagles from 1976, right? But if it's not song, so if it's movie, and there is also a movie called Hotel California, so it's completely different context, different relationships. There is ambiguity that you should resolve yourself, right? So basically, we're using the same query, but in different context, criminal movie, and now we are getting completely different results. And this is also your embedding in a way. So you can get all translations, you can get all relationships, you can get the family name of director, and that's something that you can use as a supplementary information for LM to recognize that this is something different from song, right? And what if this movie, not from 2008, but from 2013, it should be resolving to completely different concept, right? So it's semantic resolver that basically is turning any kind of free string into identifiers. So you'll get identifiers from Wikidata. You can resolve anytime. You can go to Wikidata to get JSON-LD, download all relationships, all concepts, and you can do pretty amazing stuff with it in the future. Yeah, another thing that we are building after we got this process more or less working. Of course, it's very experimental. It's not optimal, but it's working. So now we are able to create from any kind of sentence knowledge graph, which basically describes what is about. And it also understands ontology, so it's recognizing like things like categories, goals, metrics from schema.org, and it's basically producing graph with all relationships that you can fit inside of LM, and LM will do a pretty good job as soon as it will be trained on these kind of relationships. So, of course, it's difficult to deal with AI right now without agents, and everybody is talking about agents, right? So, my advice to start with really small library, and Hugging Face did a good job. So they created this small agents library, and of course there is a new library from Anthropic and from other vendors. But this is really good start because a couple lines of Python code. You can connect, for example, like to get some temperature from some place and some data from another place, integrate, ask LM to answer what is about. Like in this example, I'm asking what was the temperature in Amsterdam. And basically, it's easily like combining different sources and bringing you back answer, which is based on real factual data. Yeah, another tool, and I really advise you to take a look at this. It's Microsoft, but it's good. apparently. So it's called Mark It Down, and it can turn any kind of content, any kind of PDF, any kind of spreadsheet into AI-ready representation, and you can basically connect it to AI, and you can do something useful as well. Yeah, and last thing I wanted to show. So we are also working on local implementation of AI, and there is a tool that I've created. I call it Ghostwriter, and basically it's a local LM that does integration of any kind of information like guides, manuals, GitHub issues, Google Threads, a lot of stuff. So can be any kind of PDF and any kind of information. And the whole point, it's local. It's deployed on a server, and basically now we're using we are using this tool as a kind of knowledge base. So people just basically add in their pages they would like to ask about something, like documentation pages, and they can also use like crawler to get the whole website inside of semantic index. And after they're just asking questions, how to do that and that and that, and it's bringing you advices. So that's something I also advise to follow. If you have a lot of information, you also need to think how knowledge will be organized in a structured way. It's also powered by knowledge graph. So that also means that as soon as you will have this knowledge in the knowledge graph, you can also use other models, not only Llama or Mistral or, I don't know, DeepSeek, but even new models that will be trained next years. You can connect to this source and it will still respond, and you'll get trusted results. Yeah, so if you're interested, I did a talk for Harvard some time ago. There is also a video in the links. And yeah, if you have some questions, just approach me and I will be happy to help. I'm also a judge in this event. Thank you.
Do we have any questions from the audience?
Yeah.
Hello? Okay, now it works. So basically, Croissant is in between these, like, all kinds of different data structures, like genomic data, and then translate that ready for an LLM, or? So it looked really, really interesting, like a missing piece to a lot of issues.
That's right. So we envision Croissant as a kind of librarian. So you can think about large language model where people just basically getting all stuff, ingest it in a model, they're training on this without understanding that this information can be also contradicting. It can be coming from books published in different years. It could be like difference in centuries between knowledge from both books. And you're expecting something meaningful coming as an answer, right? Which is not true. So instead, what we actually did, we created like virtual library where AI, instead of like giving you answer, it can bring you a lot of suggestions. And it will bring you also data sets. And now you can go to specific data set. Basically, you can find any book, right? And you are going to from library level to expert level, because in this data set, you will get all these expert keywords describing what is inside, right? And now you can basically ask questions, and it will be consistent because it will be coming from one author who is probably expert. And we have all provenance chains, so we have author fields, author registered in the fields. So we know that we can trust this guy who is responding to us, right? Or if there is some data set collected by some group, research group, we can also see this information is coming from some research, and this research has founders and research outputs and some papers. So you can basically get very quickly to the knowledge layer, explaining you how and what they did and what is the result. Yeah, that's Croissant. More questions?
Does anyone else have a question for Slava?
Do you know of any agents that are currently able to work with the Dataverse kind of what you showed about querying data or reacting to what's on Dataverse and searching through it?
Yeah, so we have some implementations, and it's very experimental, so we are not sharing yet, but it looks very promising. So we can do, I think, a lot of stuff in very near future with it. And of course, it's ongoing work, so everybody is happy, is welcome to join, and will be happy also to get any kind of feedback.
And just to clarify, the work that you do for Dataverse is open source, yes?
Yes, it's open source. Everything is open, and if you'll go to Harvard, you'll find a lot of open repositories, and yeah, just use that. Don't reinvent the wheel, please.
Does anyone else have questions for Slava? Yeah.
Hi, thank you for the amazing talk. A question on how this is connected with European infrastructures like EOSC.
Okay, it's Dataverse is basically what I just showed. It was developed as EOSC projects. So we had Shock, and in Shock we actually contributed external vocabularies plugin that allows to connect to control vocabularies, and we are also actively participating in different Horizon 2020 projects, and the Dataverse is also kind of one of the biggest, largest data repositories in Europe because of that.
And maybe related to this, about data harmonization, you know, if you can select different databases or datasets that are on the same, how is that working? Because it's a long-lasting problem in science.
So currently we are working on a few projects, also in Netherlands, trying to harmonize data sets. So we're basically turning non-structured data into structured data, and it's, you know, in Dataverse we have a lot of metadata fields which are automatically predicted what to fill. So you're getting like string, and based on information you have in this string, it can recognize this is title and this is description, and this is keyword, should go to keyboard, and basically you can create completely automated record and process that will deposit everything in Dataverse without human. And after human will be basically checking what is being deposited, and will correct also if there is something wrong. It's possible, yeah.
And one last question, Slava, before we break for lunch. There are quite a few hackers in the Discord. Some folks have already posted links to your slides just so that other people can go in and look at the information they're in. You will be on the Discord, so if anyone has questions, it's okay for them to reach out.
Absolutely, yeah.
Awesome, wonderful.
Thank you.